Hello, guys. My name is Desmond, and I welcome you to my YouTube channel, ladies and gentlemen. For today, we'll be looking at question number 4 of Physical Sciences, paper 1. So this is in preparation, for the exam that we'll be writing on Friday. So, ladies and gentlemen, if time will still be on our side, we're going to quickly do this question. And again, as soon as we're done, we should be focusing on this question. So this is part of work, energy, and power. Okay, so hopefully we'll be able to quickly go through this question and start with another question. So, ladies and gentlemen, I wish you all the best on an exam that you'll be writing on Friday. And most importantly, ladies and gentlemen, please do make sure that you stay with me until the end of the lesson, because I believe if you can fully understand what I'll be explaining to you, you will be ready for your exams. Okay, so I've already got a positive feedback from most of you who watch my lessons that they are easy to understand. So that gives me the energy to continue with creating more and more content. So, ladies and gentlemen, without any waste of time, let's quickly start with our question for today. Obviously, what I'm going to do is to quickly read through the given statement, try to analyze the given diagram, and obviously answer each and every question, and most importantly, ladies and gentlemen, show exactly where you score your marks. Okay, so we're given a statement which reads as follows. So the diagram below shows a car of mass m traveling at a velocity of 20 meters per second east on a straight level road, and a truck of mass 2m traveling at 20 meters per second west on the same road. Ignore the effects of friction. So, ladies and gentlemen, from the given statement, you just need to notice that you've got a car and a truck. Very, very much importantly. So this is a car and this is a truck. So that means when you continue with your calculations, bear in mind that they refer to this as a car and they refer to this as a truck. So in which direction is the car moving? In which direction is the truck moving? Ladies and gentlemen, at all times, to the east is towards your right hand side, to the west is towards your left hand side. Okay, so it's in most cases where we refer to the east or towards the east as a positive direction and towards the left as a negative direction. It's normally based on the fact that when you draw a Cartesian plane, you've got your x-axis on this side being the positive side and on this side being the negative side. Okay, also in terms of objects moving up and down, we know up it's mostly taken as positive, down as negative. Reason being, on this side of the Cartesian plane, of course, you've got positive sign towards the right, a negative sign towards the left, negative sign downwards or southwards. Obviously, this will mean northwards or upwards. Okay, very, very much important, ladies and gentlemen. So, let's now continue with our discussion focusing on the given diagrams. Most importantly, ladies and gentlemen, obviously, these are moving objects. Okay, at what speed, at what velocity? Okay, obviously they've indicated that the truck is moving at 20 meters per second towards the left. the car it's moving at 20 meters per second towards the right. Very, very much important, ladies and gentlemen. Obviously, guys, the car has got its own mass. The truck has got its own mass. Very, very much important, ladies and gentlemen. So now, what is the mass of the car? It's 1 m. Okay, so that means it's just m kilograms. So that m, ladies and gentlemen, is the mass of that car in terms of m. Okay, do not be confused if you're not given the exact value of the mass. Okay, so the mass of the truck, ladies and gentlemen, is 2 m kilograms. Okay, very, very much important, ladies and gentlemen. It's very, very much important that you fully understand the information that you're given. Okay, so in simple terms, what does it mean? So it means you know, the truck, it has got double the mass of the car. Okay, so that means you know, the truck is 2 times heavy, or is 2 times you know, heavier than the car. Very, very much important, ladies and gentlemen. But you do not need to worry that much about this being 2 times the mass of the car. Okay, you just need to know or bear in mind that the mass is just m for the car and the mass is just 2m for the truck. Okay, so you will understand how to use this type of given information when you substitute into the formula. That's in case if they want us to calculate either the velocity or the mass or whatever. It will obviously depend on the question. Okay, so ladies and gentlemen, I'm not really sure if so far you fully understand that given statement in relation to the given diagram. So obviously you've got a compass over there where they indicate upwards it's north, towards the right it's east. Okay, so because in this case we're not dealing with objects moving up and down, so that means our main focus is on that you know, axis. So obviously on this side it will be towards the west. Okay, so ladies and gentlemen, let's try to have a look at our first question. Obviously this will serve as a guide in terms of you know, how to use the information on the given statement. So remember guys, if you're not able to see what's written on the screen of my tablet, most of you guys have got my WhatsApp number. You can just drop me a WhatsApp text requesting the question paper. But one thing for sure, I do post question papers on my Telegram channel. If you've got a Telegram account, you can just search for Solving Exam Papers. That's where you should be able to access all the past question papers that I've posted there. And remember guys, not only for you know, the subjects that I treat, but for all high school subjects, and that includes accounting, businesses, history, etc. Okay, so without any waste of time, ladies and gentlemen, let's now have a look at our first question. So the question says, calculate the velocity of the car relative to the truck. And this question is allocated 2 marks. Ladies and gentlemen, at all times, especially when it comes to physical sciences paper 1, ladies and gentlemen, please do make sure that you fully understand what the question wants you to calculate, or otherwise what the question wants you to provide as an answer to the question. Okay, so this is how you do it. Ladies and gentlemen, they say calculate the. What is it that they want you to calculate? Obviously, ladies and gentlemen, they want you to calculate the velocity. So that means 4.1 wants you to calculate the velocity. So now that you know that they want you to calculate the velocity, it means your answer should be in meters per second. Okay, do not write anything which is not in meters per second. Okay, so that means whatever that you write, its units should be meters per second. In that way, you know you're not in any way going to be giving a mass which is in kilograms as part of your answer. You're not going to give anything else other than a velocity which is measured in meters per second. Ladies and gentlemen, ask yourself this question: what velocity are they requesting me to calculate? Okay, very, very much important, ladies and gentlemen. So that means they want you to calculate the velocity of the car. So they want the velocity of the car. Why did they have to specify that you must calculate the velocity of the car? It's because, ladies and gentlemen, you've got two objects over there, which is the car and the truck. Okay, so now in the question, they want you to calculate the velocity of the car relative to the truck. So relative to the truck. Okay, so they're saying at what speed is that car moving relative to the truck. Okay, take into consideration that the truck is also moving. Okay, so that's why this question is a bit tricky. What makes it to be tricky is for the fact that that truck is also moving, and what matters the most is to take into account the direction in which it's moving. Okay, very, very much important. So now I'm going to remove my tablet. Obviously you understood the question, ladies and gentlemen. So now we are on question number 4. Okay, so let me just remove this information and just draw something like that, ladies and gentlemen, and draw a truck. So this is that truck. Okay, so remember guys, this is moving in that direction at 20 meters per second. This is also moving in that direction at 20 meters per second. Ladies and gentlemen, before I go deep with this question, if I wasn't explaining to you, I would have straight away given the answer, but it doesn't necessarily mean what I'm doing now. It's what you need to do in the exam. Just give an answer which is going to be allocated 2 marks. And I'm going to show you exactly where that 2 marks comes from. Okay, so remember guys, you've got what we call a vector quantity and a scalar quantity. Very, very much important, ladies and gentlemen, that at all times you remember that in physical sciences you've got a scalar quantity and a vector quantity. Okay, so these things, ladies and gentlemen, the mass, the time, the speed, velocity, frequency, gravity, distance, what else, ladies and gentlemen? It's a lot of them, these quantities that we use in physical sciences. So ladies and gentlemen, whatever it is, okay, I'm just trying to think if I missed something, but otherwise I think you know what I'm talking about, ladies and gentlemen. So these are what we call quantities. Okay, so ladies and gentlemen, you've got a mass which falls under scalar quantity. You've got speed, which is referred to as scalar quantity. Frequency should be a scalar quantity. You've got distance. You also have what we call a displacement. So obviously a distance, it should fall under a scalar quantity. Time also, it should fall under scalar quantity. Quantities like gravity, acceleration, velocity, displacement, ladies and gentlemen, they fall under vector quantities. What are these vector quantities? So a vector quantity, it's a quantity that has a value and a magnitude. So a value which is a magnitude and a direction. Okay, so it could be, let's say acceleration, it can be 2 meters per square second. Okay, this is what we call a value, this is what we call a magnitude. Then followed by either upwards, downwards, to the right, or to the west. Then this is the direction of this magnitude. Okay, a distance, not necessarily a distance, but a displacement, it's what falls under vector quantity. So a displacement, you can have a displacement which is negative 2 meter, which could be positive, let's say 4 meter. So that negative, ladies and gentlemen, it serves as a sign to say this is a distance measured maybe when the object was covering a distance upwards or a distance downwards. Then you've got a velocity which could be 7 meters per second, eastwards, to the right, westwards, to the left, upwards, towards the north, downwards, or southwards. Okay, so these are the quantities which have a magnitude or a value, which is the amount, and again the direction in which they are moving. Okay, very, very much important, ladies and gentlemen. So when it comes to scalar quantities, it's just a time which is known to be 2 seconds or whatever. It's the mass, which could be 2 kg or 2 grams, whatever. You've got the distance, which is just 7 meters or kilometers. You've got a frequency, which could be 150 hertz or whatever that it is. So in short, ladies and gentlemen, when it comes to time, you will never have 2 seconds to the left. Okay, you will never have a 9 kg upwards. You will never have a distance as 50 meters or 100 kilometers to the right. Same goes for frequency. It's just a magnitude. Ladies and gentlemen, time has got no directions in physical sciences. Time falls under scalar quantities. Okay, very, very much important, ladies and gentlemen. Why am I telling you this information, ladies and gentlemen? Remember, the question said calculate the velocity of the car relative to the truck. So the velocity that they want us to calculate, is it a scalar or a vector quantity? It's a vector quantity, ladies and gentlemen. What does it mean when it's a vector quantity? It must have a magnitude or value and a direction. Okay, which is a good indication that 1 mark might be allocated to the magnitude and the other mark might be allocated to the direction. Okay, so for the fact that a mark is allocated for the magnitude, it means it's not that much complicated, ladies and gentlemen. You just need to fully understand what's going on over there. Remember, guys, this truck, it's moving at 20 meters per second. This car, it's moving at 20 meters per second. So when you look at this car relative to that truck, it's more like this car is moving 2 times faster, or it's like it's approaching this truck 2 times faster. Ladies and gentlemen, let me first answer this question. I'll give you a few examples of which I hope they will make you understand. Okay, so that means this car relative to that truck, the velocity of the car is equals to 20 meters per second plus 20 meters per second, which is 40 meters per second. In which direction, ladies and gentlemen? In the same direction in which the car is moving. So you can say 40 meters per second east or eastwards, or to the right, or to the right, ladies and gentlemen. So guys, let me just remove this part, and then from there I'm just going to give you scenarios just to help you understand. Okay, so remember, guys, let's say, for example, you've got a, let's say this is case A. Okay, this is case A. Let's say, for example, ladies and gentlemen, this car was moving in that direction or to the right. Let's say it was approaching this truck, this truck which was, not moving. So obviously that means its speed is 0 meters per second, and the car is moving at 20 meters per second. So, ladies and gentlemen, when we compare the velocity of the car relative to the truck, okay, so obviously this is approaching the truck at 20 meters per second. So that means the velocity of the car relative to the truck will be 20 meters per second plus 0 meters per second, which is 0 meters per second. Okay, so when we do these calculations, ladies and gentlemen, we take into consideration the direction in which this is moving, and this is only to help us to give the direction. Okay, so obviously because we're talking about the car, ladies and gentlemen, so in which direction is this car moving? Obviously to the right. So that's when you can say eastwards. Let's maybe have a look at case B. Okay, so ladies and gentlemen, let's say a car was traveling in that direction, okay, and then the truck was also traveling in the same direction, and this was traveling at 20 meters per second. Let's also say it was traveling at 20 meters per second. Ladies and gentlemen, the velocity of the car relative to the truck, ladies and gentlemen, it's more like, if you have a look at these two, okay, this is traveling in that direction, this is traveling in that direction. So it's more like they are not moving, ladies and gentlemen, because for every second they cover the same distance. Okay, so it's more like after every second the truck covers 20 meter. After every seconds the truck covers a 20 meter. Okay, so ladies and gentlemen, this is how the movement looks like. I hope you're able to see. This is the truck and this is the car. Okay, so this is the movement, ladies and gentlemen. This is the movement. Can you see? They are both traveling at the same speed. Okay, so the speed of the car relative to the speed of the truck is equals to 0 meters per second, ladies and gentlemen. Let me just try to repeat it for the last time. I hope when I did it for the first time, I said this is the truck and this is the car. Okay, so in this case, they're both traveling at at 20 meters per second, traveling at 20 in the same direction. So this is what happens, ladies and gentlemen. This is the car. So have a look at the speed of the car relative to the speed of the truck. Okay, so they're both moving in the same direction at the same speed. Can you see, ladies and gentlemen? Nothing is getting closer towards the other thing. So that means the car is not in any way getting closer to the truck. That's why it's 0 meters per second. Okay, so this case, ladies and gentlemen, this is where this is moving at 20, this is moving at 20. Okay, so you now have a truck and a car. Okay, so they are approaching each other. So now this is traveling at 20, this is traveling at 20 meters per second. So this is the speed, ladies and gentlemen. Can you see? So when you compare the speed of the truck versus the speed of the speed of the car versus the speed of the truck, it's more like this is moving at 2 times the speed, because it's 20, ladies and gentlemen. Can you see? So for it to make a perfect sense, let's say the truck is not moving, let's say the car is moving, obviously at 20 meters per second. Okay, so this is what happens. Can you see, ladies and gentlemen? So if it's only the car which is moving, you can see is 20 meters per second. What if they are both moving at the same speed? Can you see, ladies and gentlemen? So it's more like this is moving at 40 meters per second relative to the track. It's different from when this object is moving alone and not being compared to anything else. Okay, very, very much important, ladies and gentlemen. Very, very much important. So they allocate a mark for that 40 meters per second, and they give you a mark when you said to the right or eastwards. So ladies and gentlemen, this is how you score 2 marks for this question. I'm not really sure, guys, if you understood what I was trying to explain to you over there, ladies and gentlemen. Okay, the last case, ladies and gentlemen, the last case of which it's something that they may ask. Let's say this is the car traveling in that direction at 20 meters per second. This is the truck traveling in that direction. Let's say it's at 40 meters per second. Okay, so now they're asking maybe what is the speed of this relative to the truck. Okay, so obviously, ladies and gentlemen, as this car is approaching the truck is moving away 2 times faster than that. Okay, so obviously, ladies and gentlemen, it seems as if this is moving in the opposite direction, obviously at 20 meters per second. So let me say at 20 meters per second. In which direction? Obviously, it seems as if it's moving in the opposite direction, which is westwards. How is it the case? It's because if this is the truck and this is the car, so in this case they are not both moving at 20 meters per second, but the other one is moving a bit faster. Can you see, ladies and gentlemen? So this is now faster than this one. So when you look at these two and you specifically look at the speed of the car relative to the speed of the truck, it's more like the car is being left behind. Okay, so it's more like the car is delaying by 20 meters per second because the truck is moving faster. Okay, so that's why it seems as if it's moving at 20 meters per second, but in the opposite direction, or otherwise it seems as if it's been moving or it's being left behind by 20 meters per second. Okay, very, very much important, ladies and gentlemen, that you understand that part. So now I think we can move to the second question, ladies and gentlemen. I pray that you fully understood that part, because this type of questions, ladies and gentlemen, they can also ask you this question in multiple choice type of questions. Ladies and gentlemen, let's now move to question 4.2. There's a mini statement given there which says the vehicle collide head on and stick together during the collision. Okay, so that means what happens is it's moving at 20, it's moving at 20, they collide head on and move together. Okay, what we don't know, ladies and gentlemen, as soon as they stick together during the collision, is that we don't know if they move in that direction or they move in that direction. Okay, so we can only know after performing some calculations. Okay, so but based on the information that we are given, we can obviously assume the direction in which they will move as soon as they collide and stick together. Okay, so ladies and gentlemen, 4.2 state the principle of conservation of linear momentum in weights. Guys, do not give anything other than the principle in weights. Very, very much important. So you obviously have this principle of conservation of momentum, of linear momentum in almost every textbook, ladies and gentlemen. It's stated. So it's just a matter of you giving what you know. Okay, so your teachers also teach you this information. So you can easily say the total linear momentum is conserved in an isolated system. Okay, so obviously that's a system where there are no external forces. Okay, that's why it was indicated that the force of friction may be ignored. Okay, very, very much important, ladies and gentlemen. So this question is allocated 2 marks. Okay, so by just stating the principle of conservation of linear momentum, they give you 2 marks. Okay, so ladies and gentlemen, we won't waste any much of our time on that one. I assume everyone has got a definition. So ladies and gentlemen, you need to make sure that you know these definitions by heart, okay? Because you might be asked to provide that information. So ladies and gentlemen, let's now move to question 4.3. Calculate the velocity of the truck car system immediately after the collision, and this question it's allocated 6 marks. Ladies and gentlemen, it's a lot of marks, but a lot of easy marks. Okay, so ladies and gentlemen, we are now on question 6.3. Okay, what does the question want you to calculate? Ladies and gentlemen, they want you to calculate the velocity. How does your final answer how is it supposed to look like, ladies? Very, very much important that you ask yourself this type of questions. So they want you to calculate the velocity of the truck car system, ladies and gentlemen, immediately after the collision. So that means your final answer should be anything in meters per second. Obviously, you might need to give the direction. Why? Because this is a scalar, this is a vector quantity, ladies and gentlemen. What does it mean when it's a vector quantity? Means it has a value and a direction. Okay, so that means if you just give the value, you might lose a mark for the direction. Very, very much important, ladies and gentlemen. So obviously, guys, the direction, you must either have westwards or eastwards. Very, very much important, ladies and gentlemen. Very, 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 very much important. Okay, the other important thing is that your velocity, ladies and gentlemen, your velocity must be less than 20 meters per second. Why is it supposed to be less than 20 meters per second? It's because obviously, ladies and gentlemen, these are 2 cars which are approaching with each other at a speed of velocity of 20 meters per second. As soon as they collide, there's no way their velocities can increase. Unlike if this was moving in that direction and this was also moving in the same direction, but this one at a higher speed such that it hits this one. Maybe that's when we can have a velocity of this as greater than its initial velocity. I'm not sure if it makes sense, ladies and gentlemen. So you just need to apply your mind on this type of questions, ladies and gentlemen. There's no way after collision a velocity can increase. Okay, so this serves as a guide that if we get a velocity which is greater than 20 meters per second, then we should suspect that something during our calculations went wrong. Okay, so obviously, ladies and gentlemen, the first thing to do, not not 6.3 but 4.3, the first thing that we need to do is to write the formula, ladies and gentlemen. The sum of momentum initial, it's equals to the sum of momentum final. Okay, what matters the most, ladies and gentlemen, is for you to know that momentum, it's equals to mv. Okay, very, very much important. What does it mean by that sum? It's because you've got two vehicles approaching with each other, or you've got two vehicles in motion. So that sum, it means you then need to add the momentum of these two vehicles. That's why, ladies and gentlemen, you've got the sum of momentum as mv plus mv. Okay, what's the difference, ladies and gentlemen? This is for the mass 1 or mass of the car, and this will be mass 2 or mass of the truck. This will also refer to the velocity of the car or the velocity of that first object. So that will be the velocity 2, which refers to the velocity of the second object. Okay, so ladies and gentlemen, because this is the sum of momentum final, then this portion focuses on the final scenario, then this will focus on the initial scenario. Okay, what is the initial scenario? This is before the collision. This is before these two objects touches with each other. What is the final situation? This is when a collision has taken place. This is when these two objects has come to contact. Okay, so very, very much important, ladies and gentlemen, that you understand this formula. So now I'm just quickly going to expand it such that it suits the scenario that we're given. Okay, so obviously we know momentum is mv. Okay, and the sum means we now need to add for these two objects, so plus mv. Okay, so ladies and gentlemen, it's always best to describe the mass and the velocity over there. Okay, so this will be the mass, let's say, of the car, and let's just use c. You can still use 1 and 2, of which 1 refers to the first object, which is a car, and then 2 refers to the truck. But I like to use c, ladies and gentlemen, because it refers to the car, and then this one for the truck, and that one for the truck again. Okay, so remember, ladies and gentlemen, this is for the initial scenario, okay, which is equals to remember, guys, they've just said as soon as these two comes into collision, then they stick together. Okay, so when they stick together, it means now their mass is combined, so it's just one thing. That's why on my formula I've got the mass of the car plus the mass of the truck. Okay, very, very much important, ladies and gentlemen, multiplied by v of what? A very, 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 very a very good question, ladies and gentlemen, because this is going to then now help you to understand what you're calculating. So this is the velocity of the truck and the car. Okay, why? Because after collision they stick together. That's why even on the question they said calculate the truck car system. So now it becomes a system because that car and the truck, okay, the car and the truck, it's now one thing. Okay, so that means if they are moving in that direction, they are moving in that unity. Okay, they move together as they're sticking together. Okay, if they move in that direction, they move in the same speed, because after collision they said they stick. Okay, so ladies and gentlemen, it's either they move in that direction or in that direction. Okay, so assuming that to the right it's positive and then to the left it's negative, that means the velocity that we get, if we get a negative answer, it means after collision they move in that direction. If we get a positive number, then it means after collision they move in that direction. But I can guess, ladies and gentlemen, I can guess that it will move in that direction. Why? Because this mass is bigger than that mass, or otherwise this has got greater momentum because of it's heavy and it's moving at the same speed as that car, which is light and still moving at the same speed as the truck. Okay, if the car was moving at a higher speed, then I wasn't going to be able to guess which in which direction they'll be moving after collision. Ladies and gentlemen, as soon as you identify the right formula, then you are done. You're done, because what you do is just to substitute, ladies and gentlemen. And it's unfortunate it's already late, but for those who are still in grade 10 and 11, they'll be able to go through my lesson where I teach in full in terms of different cases that you might have as far as momentum is concerned, because you can have different situations where they collide and separate. In this case, they collide and unite. In some other cases, you've got a bullet which passes through a block where the bullet now moves at a certain velocity. You also have the block moving at a certain velocity, and these questions may extend to such an extent where you still need to calculate the impulse and whatever. Okay, so ladies and gentlemen, what we do now is just to substitute. Okay, let's now substitute. What is the mass of the truck? No, not the truck, but the car. Let's start with the car. Obviously, we know, ladies and gentlemen, it's M. Okay, this is the mass of the car multiplied by, ladies and very, very much important, multiplied by the velocity of the car, which is 20 meters per second. Take into consideration that we are saying positive to the right, negative to the left. Okay, so that's why it's just 20 there, but in your mind you know it's actually a positive 20 meters per second. Okay, plus, ladies and gentlemen, what is the mass of the truck? We know is 2m. Okay, ladies and gentlemen, what is the velocity of the truck? We know is 20 meters per second, but most importantly, it's negative 20. Why? Because it's moving in that direction, and we assumed to the left or westwards as negative. Then this is equals to, remember guys, I've just indicated that mass is one of the scalar quantities. So you cannot say it's negative m because it's not a vector quantity. It's just m. Okay, very, very much important, ladies and gentlemen. So remember, the mass of the car is just m. Okay, plus what is the mass of the truck, ladies and gentlemen? The very same mass that you substituted with on the left, which is 2m. Okay, multiplied by velocity of the truck car system. So now, ladies and gentlemen, you can easily calculate. You've got 20 times m, which is just 20m. You've got 2 times 20. You've got a minus sign there. It makes it minus, obviously, 40m, which is equals to that plus that. It's obviously 3m. Okay, remember guys, you've got v of the truck car system. Okay, so guys, you've got 20m minus 40m, so this should be minus 20m, which is equals to 3m multiplied by velocity of the truck car system. Guys, I'm sure at this stage you fully understand this mathematical procedure. Okay, so ladies and gentlemen, because this is what you're calculating for, this is what the question wants you to calculate, the velocity of the truck car system. Okay, so you obviously divide by 3m. You obviously divide by 3m on both sides. Ladies and gentlemen, why do you divide by 3m? It's because you want it to cancel so that you remain with velocity of the truck car system, which is equals to, obviously m cancels m, then you remain with 20 divided by 3. Okay, so this is where you pull out your calculator and say negative 20 divided by 3, and you get negative 6.666. So this is what I'm getting as negative 6.6. Then I can just round it to 2 decimal places, and the answer is in meters per second. Okay, remember guys, 6.66 is the magnitude. Okay, that negative, it tells us more about the sign. So let's say velocity of the truck car system is equals to, we know the speed is 6.67 at 6.67 meters per second. In terms of the direction, ladies and gentlemen, we assumed positive to be moving to the right, negative to the left. So because our answer was in negative sign, then it means it's moving westwards, okay, or to the left. Very, very much important, ladies and gentlemen. Very, very much important that you score these easy marks. Okay, so I hope you understood that part, ladies and gentlemen. So obviously we give you a mark for writing the correct formula, guys. Okay, very, very much important. So now I think you deserve a mark, ladies and gentlemen, for correct substitution. I think for correct substitution, we can just, give you some marks. Remember, guys, this question is allocated 6 marks. Okay, it's allocated 6 marks. So, ladies and gentlemen, this is you following mathematical procedure. Okay, so we just give you a mark for your final answer, and again, we give you a mark for indicating the direction. So, ladies and gentlemen, I hope you fully understand what I've done over there. Okay, so now we can move to the next question. Remember, guys, a day without learning something new, it's a day wasted. Okay, so please do make sure that by the end of each and every question, you do learn something new. Okay, so guys, let me tell you something, because you don't know nothing. Guys, we are now moving to question 4.4. Okay, so the question says, on impact, the car exerts a force of magnitude F on the truck and experiences an acceleration of magnitude A. Okay, so that was a mini statement given over there. Okay, so obviously you might find that upcoming questions might be based on that statement. I'll read it for the last time. On impact, the car exerts a force of magnitude F. So as they collide, that car exerts a force of magnitude F on the truck and experiences an acceleration of magnitude A. So the question says, determine in terms of F the magnitude of the force that the truck exerts on the car on impact. give a reason for the answer. Okay, very, very much important, ladies and gentlemen. Guys, an answer to this question is based on Newton's third law. Okay, so I'm giving you a challenge, I'm giving you a homework, ladies and gentlemen. I won't give you these easy answers, but instead I'm going to train you. So, ladies and gentlemen, if this car is exerting a force of F on the track, okay, so that means the truck is also exerting the same amount of force on the car. Why is it the case, ladies and gentlemen? It's because of Newton's third law. Okay, Newton's third law. So I'm giving you a challenge to go and read about Newton's third law and check if this will make sense. Okay, so if that car was exerting a force of magnitude 2F on the track, so that means even the truck is applying the same amount of force on the car. Okay, very, very much important, ladies and gentlemen. This question is allocated 2 marks. You get a mark for indicating the amount of force and again for the reason. Okay, so ladies and gentlemen, let's now move to question 4.4.2. Okay, so let's check what the question says. So now the question says, let's see, the question says, let's see, ladies and gentlemen, the question says, determine in terms of A, the acceleration that the truck experiences on impact. Give a reason for the answer. Okay, very, very much important. So it's very, very much important that you fully understand what the question says. Determine in terms of A. So your answer should be in terms of A. Okay, very, very much important. Determine in terms of A, the acceleration that the truck experiences on impact. And they say, give a reason for your answer. Okay, very, very much important, ladies and gentlemen. So remember, guys, you've got, I'm not sure if you're aware, but I know in most cases they teach you this thing, ladies and gentlemen, to say the acceleration is inversely proportional to the mass. Okay, very, very much important, ladies and gentlemen. The acceleration is inversely proportional to the mass. So now, in this case, the question wants you to determine in terms of acceleration, the acceleration that the truck experiences on impact. Okay, so ladies and gentlemen, remember, what is the mass of the truck? So the mass of the truck is 2. Okay, so that means there it's actually 1/2. Okay, so that means the truck is experiencing half of acceleration. Okay, so the reason to that, ladies and gentlemen, is because the acceleration is inversely proportional to the mass. Okay, so an answer to that question is a simple half of acceleration, ladies and gentlemen. What makes it to be half is because of for the fact that the acceleration is inversely proportional to the mass. Okay, so by so saying, ladies and gentlemen, you just score yourself 2 marks. Okay, so I assume you fully understand that part, ladies and gentlemen. Some of this information you can fully understand if you've gone through the lessons where I teach in detail this information, because with what I've been doing, ladies and gentlemen, I'm only teaching you on how to answer these questions, I wasn't teaching you how, you know, how do I explain this, ladies and gentlemen? I'm actually trying to indicate to you that I'm not actually giving you you know, a complete lesson where I start with the basics. The reason to that is because I assume you've already done that with your teacher. So what we're doing is just to try to do something differently. But, excuse me guys, but as of next year, I'm going to make sure that, you know, I do a course which covers almost everything, where I teach and provide the notes. Okay, so if you're still in grade 10 or grade 11 and you're watching this video, and most importantly, if you happen to repeat this module next year, just make sure that you become a very good friend of mine, because that's where you'll benefit from the notes and those lessons that I'll be doing. So I'm just going to package it as a full course. Okay, so ladies and gentlemen, let's now move to, I think this should be our last question. So they say both drivers are wearing identical seat belts. Which driver is likely to be more severely injured on impact? Explain the answer by referring to the acceleration and velocity. Okay, ladies and gentlemen, so you can easily notice where you're going to score your marks. So obviously you've got three things to comment on. Both drivers are wearing identical seat belts. Which driver is likely to be more severely injured on impact? You're going to score a mark for answering that. Explain the answer by referring to the acceleration and velocity. So, by commenting on the acceleration, ladies and gentlemen, you're going to score a mark. Ladies and gentlemen, by commenting on the velocity, you're going to score a mark. Okay, so let's now try to comment on both, ladies and gentlemen. Remember guys, remember, this is question 4.4.3. Okay, acceleration guys, acceleration is directly proportional to the change in velocity. You should know this information guys. And again, acceleration, it's inversely proportional to the mass. Okay, so in terms of direct and inverse, it means in terms of the inverse, if the acceleration is increasing, it's vice versa when you compare it with the mass. Or let me say, if the mass is more, this becomes less. Okay, otherwise, if the acceleration is more, that means the velocity is more. So I'm just trying to explain to you, ladies and gentlemen, what is meant by direct proportions. Okay, so obviously that means if let's say if you add more wood to the fire, then you increase the heat. So the quantity of wood added to the fire, or charcoal added to the fire, that quantity is directly proportional to the heat. I'm not sure if it makes sense guys. I tried to think of something which could be easy to understand. Okay, so it's more like the more you add water into a bucket, the more you increase its weight. Okay, so that means the volume, or maybe the liters of water added, is directly proportional to the weight of the bucket or whatever. So ladies and gentlemen, that's what I'm trying to say in terms of direct proportion. As the other one increase, the other one also increase. Inverse proportions, as the other one increase, the other one decreases. Okay, so guys, let's now start to answer our question. Okay, so between these two, ladies and gentlemen, between these two, which one is most likely to be more severely injured on impact? Obviously the car, ladies and gentlemen. Obviously the car. So you can just say the car driver in this case. The car driver is most likely to be severely injured when you compare with the car driver. Okay, very, very much important, ladies and gentlemen. Why? It's because the car has got greater acceleration. Okay, so you can just say the car has got greater acceleration. So that means injuries come as a result of greater acceleration. What does it mean when we've got a greater acceleration, ladies and gentlemen? Because acceleration is directly proportional to the velocity, then it means you have greater a change in velocity. Okay, very, very much important, ladies and the reason why we mention these two is because they said in terms of acceleration and velocity. So we need to provide our answers by commenting on the acceleration and the velocity when comparing these two. Okay, so obviously, ladies and gentlemen, the car driver is most likely to be severely injured when compared to the truck driver. Okay, remember guys, if M is it's inversely proportional to the acceleration. So obviously this is 1m, this is 2m. Okay, so now you've got 2m, it makes it a less of acceleration. Okay, you've got 1m, so it makes it a more acceleration when you compare these two. Okay, very, very much important, ladies and gentlemen. So that means because the car has got more acceleration, it means it has more change in velocity. Okay, so guys, as I've said, you will only have a better understanding of this the moment I do those lessons. Okay, so ladies and gentlemen, this is how you solve for this question, and you score yourself you score yourself some 3 marks for the last question. So I think, ladies and gentlemen, we can just leave it here, and then from there we'll proceed with that question that I indicated on a separate video, of which I assume I'm going to do that video tomorrow, ladies and gentlemen. But I hope you fully understood exactly what I explained over there. I've done some more videos in relation to momentum, so you can just go to my YouTube channel under playlist physical sciences. That's where you'll find those videos. Ladies and gentlemen, thanks very much for joining, and I hope you enjoyed as much as I did. Please make sure to like this video if you feel like it's going to help you to approach those exam questions. And most importantly, please do comment on the comment section just to give me a feedback. And again, if there's something that you didn't understand, you can just send me a WhatsApp voice note. Then I'll surely be able to assist as soon as possible before you write your exams. Ladies and gentlemen, thanks very much. My name is Desmond, and I'm out.